All right, so I cleaned up these slides this morning when I woke up a little bit too, because it wasn't going so clean yesterday. So here's a simple piece of code. And if you're taking 2001 from me this term, this function was on the test last week. And so what's true about it is though it's really a simple piece of code, it grows extremely fast. All right, so fast that if you ask what is the output when you input 5, 5, unless you've seen this before, you will never come up with a number that this is this big. It's just so big, right? It's like that Monty Python. Oh, God, you were so big. Right? It's just like that. All right, so here we go. Let's first say Ackermann's function. Let's break it down into levels. So we're going to say we have each k, we're going to have a function of n, right? And then if you kind of see what it's doing, right, there's a base case, and otherwise what's tk of n? Well, you take tk of n minus 1, right, so that's a recursion, and your friend gives you this, and then you apply tk minus 1 to it. And what does that effectively give us? It gives us that the kth function, the way you get it, is you start with some base case. Let's just assume this is 0 or 1. And you apply the previous t function, k minus 1 function. You apply it over and over and over on top of itself n times. Right? That's what we're doing. So if you didn't quite get it, let's get some examples. So what's the 0 function? If k is 0, you just add 2. Right? So we know what the k0 function is. Right? So this is what I said before, right? And this is the 0 function we're adding 2. So now the k1 function, right? What is it? Is you start with, say, 0, and you add 2, you add 2, you add 2 n times, right? And what does that give you? Gives you 2 times n, right? All right, so that's what the first function is it multiplies by 2. Now, what's this guy? It's going to be 2 times 2 times 2 n times, right? And what's that going to be? It's going to be 2 to the n, right? Then what's the third function? Well, we go 2 to the 2 to the 2 n times. You get the stack of 2's, all right? Now, if you might not appreciate how big this grows, all right? So let's just study the third function for a while for various values of n. This is what I added today, focusing on 3 instead of going to 4. All right, so let's focus on 3. Here I put them all together here. Right? What's T2? Well, it's a stack 2 high, which is 4. And what's T3? It's a stack 3 high, which is 2 to the previous answer. Right? So 2 to the 4 is 16. And what's 4 is 4 high, which is 2 raised to the previous answer, which is now we're getting a little bigger. Right? And what's 5? 5 high, which previous number, which is now big, right? Look how many zeros we got there, right? And just so we appreciate it, the number of atoms in the universe is bounded by this. And actually, here, this is a very rough approximation. The way I got this is the size of the universe is about 10 to the 50, and the size of an atom is about 10 to the minus 50. So if we pack the universe filled with atoms, that's how many atoms you get. It's not taking into account the empty space, right? So this is just much bigger, right? Instead of 100 digits, we have 2,100 digits. Right? Everybody follow that? And so then if you go the 6, right, it's a stack 6 high, which is 2 or 10 raised to the power of the previous number, right? So now the 6th the third function applied to 6 gives us a number with the number of zeros is the number of atoms in the universe. Right? So we're getting to be big. All right, everybody appreciate that? All right, so now what about T4? So T1 is a stack 1 high, which is just 2. And now we take this answer and get a stack 2 high, which is 4. And then we take this answer and get a stack 4 high, which is this. And then you take this answer and you get a stack this high, right? Well, we just saw that a stack 6 high was big. So a stack that high is bigger. All I can say is that it's big, right? Everybody kind of appreciate this a little bit? And so then that's big. And then if you ask what's T55, I just can't even talk about it, right? Everybody kind of got that? And that is the end of recursion.